probability and manual distribution. So next two classes we will be discussing capacity outage table. Okay. So what is capacity outage table? That we will discuss. Capacity outage tables. Write down the heading capacity outage tables. So we will summarize this. Any system, okay, we will first make the generation model. We will first make the generation model. Generation reliability model. Okay, so that will be combined with the load model. And when we combine these two, we get the system reliability model. Okay. So system states to be combined to form two-state system. Two states means success and failure. So two-state system, it means one group of states to be classified as success and others as failures. Failure state, success state. Now, you may consider success to be generator up and running. Okay. Whereas failure state should be generator down. But that depends on you. You can suppose your objective is to know how much times the generator will be down. In that case, you can consider success to be generator in operation. Your choice. However, in practice, some of the states may not fall into either of the groups. So, as we will see further, some cases it will be neither success nor failure. It will be partial capacity. Okay. For example, a process plant will be running at full capacity with no failures. Zero capacity because of total failures and derated states. Write down these three: full capacity, zero capacity, and derated state. Write down. So this type of problem may be solved by reducing the capacity outage probability table. So capacity outage table is also known as capacity outage probability table, which is developed using binomial distribution, okay, and mathematical expectations. Binomial distribution and mathematical expectation. COT is a simple array of capacity levels and the associated properties. So you must write. So first you should write. The first point is that you can have generally two states, success and failure. The second point is that in general you can have three states: full capacity, zero capacity, and derated state. And in the third case, what is the definition of the how the capacity outage table is obtained? By means of binomial distribution and mathematical expectations. And finally, COT is a simple array of capacity levels and the associated probabilities of existence. So write down the definition. COT is a simple array of capacity levels and the associated probability of existence. Okay. So a particular situation will be shown and it will be found out what is the probability of that particular situation. For example, generator generating this much amount what is the corresponding probability. So that is known as capacity outage changes. Right now the last one. COT is a simple array of capacity levels and the associated probabilities of existence. Okay? Done? COT is a simple array of capacity levels and the associated probabilities of existence. Okay. Now, power system assessment. Okay. For this reliability study, we generally find out one quantity measure of reliability index. For example, just now you have heard that PSLV failed. Okay. To install satellites. The PSLV is a highly reliable system. Never failed. But there was two successive failures. Okay. So some kind of reliability index which measures how much you can trust. Okay. PSLV was a much trusted vehicle. Okay. So what does COT provides? We'll see in the problems. The COT provides an indication of probable capacity deficiencies for each alternative, but do not indicate the relative reliability metrics. Okay. They will only show you the probable capacity deficiencies, but never the relative reliability. This can be done by using how much load is not satisfied or load loss. Okay. This we will see later. So from COT we obtain the reliability index. Okay. The reliability index. So first step is obtaining the COT. A comparison of relative reliability metrics is difficult as the investment cost is increases. Therefore, in deciding the most appropriate system, the balance between cost and reliability must be achieved. So what is reliability index? Just write down this definition. Only this definition you write. The reliability index of the expected load loss indicates the amount of load which cannot be supplied, but gives no indication of the expected number of hours for which it operates. Okay. It only gives you one probability. Okay. The amount of load loss. So this can be achieved by evaluating the expected load curtailment index. This we will see in the next 4, 5, 6, 7 classes. So we will discuss loss of load probability. They assume that the plant is to be used continuously, that is for 8760 hours or years. Then the expected load curtailment can be obtained. So once you got the reliability index, as you can simply multiply with 8760 to obtain the number of hours the generator will be out for the whole year. Okay. Got it? Only this much you write. What is reliability index? It is just a number, it's a probability, but only when the duration of the run is known, exact number of outage is known. So this is the problem that I am going to solve. So here I will show you how it is done in Excel, but in the exam you have to manually compute. Okay. So you should know how to compute the combinations. So what is the problem? The problem is that there is a small generating plant, okay, which is to satisfy a constant 10 megawatt load. We have 10 megawatt load. The load is 10 megawatt. So just to mention that load is 10 megawatt. Load is 10 megawatt. Now what are the 4 alternatives that you give? So you can have only one 10 megawatt unit, 2 10 megawatt units, 3 5 megawatt units, and 4 into 3 1.3 megawatt units. So which system will be more reliable? Okay. Which system is more reliable? That will compute. How to obtain that? In reliability evaluation, we use one concept known as the forced outage rate. Known as the forced outage rate, also abbreviated as FOR. Now in this case, FOR is 2%. is 0.02. That means the failure probability is 0.02. FOR is nothing but the failure probability. Why forced outage rate? Because many cases the generator is out because either for maintenance or giving fault. It's a forced outage. That is nothing but optional outage of generator. So first we will build the capacity outage table. Then we will find out if the FOR is 4% and 6%, then what affects the reliability, the comparative reliability of this code. Okay. So we will refer to this Excel sheet. Okay. You have to do it manually, you can do it, but in Excel it becomes very simple to represent the system. So we'll see the Excel sheet. Okay. The question is clear now. We have 4 alternatives to meet a load of 10 megawatt. FOR 0.02. So which is the best? Okay, which is the best configuration? This is our system. Post outage rate of 0.02. Okay, given here. Load is 10 megawatt. So I have given here only in the Excel because this value will be used. So as you know how to obtain, what is this value? This is D6, D column, 6th row. So if you want to refer to this 10 megawatt, then you need to simply say D6. So D6 means 10 megawatt. So these are our 4 configurations, 1, 2, 3, 4. In one case it is 10 into 1. Okay. Number is 1. 10 into 1. 10 into 2, 20 megawatt. Then 5 into 3, 15 megawatt. 3.33 into 4. Okay. 3.33 into 4 by 380 given in the question. So total is this. So these are the 4 systems. The first one is 10 megawatt capacity, next one is 20 megawatt, 15 megawatt, and 13.33 megawatt. So which one is the best? Okay, among this. So for 1 into 10 megawatt unit, this you have already written. This question part you have already written. So now you one by one you write. Okay. So first is the probability of 1 plus 10 megawatt unit. Okay. So this you will not repeat. So I have written this because that will be used in the Excel. FOR is 0.02. So you write like this. Okay. So you write like okay. So write like this. Units out. Units out. First column you write units out. Capacity out. Okay. Then megawatt available. Okay. And finally individual hours. So these 4 columns you make. Okay. First you write you have only 1 unit here. You have only 1 unit here. So you can have either 0 unit out. That means the 1 is running actually. Or 1 unit out. So there can be 2 conditions. So what is the capacity out when no units are out? Capacity out is 0. All the capacity is in service. The opposite of this is all the capacity is in service. Now in this case, what is the capacity out? When generator one generator, what is the capacity out? It is load over those 10 megawatt. Because there is only one generator of 10 megawatt capacity, so capacity out is 10 megawatt. So what is the available capacity here? 10 megawatt. Here the available capacity is 0 megawatt. Here the available capacity is 0 megawatt. Now how to find out the individual probability? So as you know, this is a binomial distribution case, only successive failure. So we have got what is the formula for binomial distribution? NCR. So what is that? P to the power R power n minus. Okay, that is the formula for binomial distribution. Now in this case, what is that formula? That is 2CR. 2CR. What is P here? What is P here? 0.02. So in this case, since we are considering the outage case, so we are considering the outage to be success because we want to find out the outage probability. So this is 0.02 to the power R. Okay, so 2CR 0.02 to the power R. What is Q? Q is 1 minus 0.02. Okay. Q is 1 minus 0.02 to the power n minus R. N is 2, so it is 2 minus 1. Now, this is equal to 2CR 0.02 to the power R and 0.98 to the power 2 minus 1. Now, what is the R value in this case? What are the R values? 0 or 1. Okay. So you can have 0 units out or you can have 1 unit out. So what is the first probability which is given here? This one should be equal to, this one is equal to 2C1 0.02 to the power 1 0.98 to the power 2 minus 1, that is 1. No, sorry, the first case is 0, right? 0, 0.02 to the power 0, 0.98 to the power 2 minus 0, which is 2. No, here I have made a mistake. It is 1. Total number of units is 1 here, right? Total number of units is 1. N is equal to 1. So this is 1. 1, 1, 1. So this is 0, 1, minus 0, 1. Okay? 1 minus 0, 1. This is getting. So total number of units is 1 here. N is equal to 1. So this becomes, this is 1, this is 0 is 1. 0.0 is 1 and 0.96 per 1 is 0.90. Okay. Whereas in the other case, the second case, 2C1 0.02 to the power 1 because it is 1 and 0.98 to the power 1 minus 1, that is 0. That means it is 0.2. So when you add this up, this individual probability, it should add up to 1. Otherwise there is a mistake. Okay. So now
First, yes.
These are 1C1, 1C0, 1C1. Okay. So now we'll see how it is done in the Excel. So if you see here, so I have used the formula combine. See here. Combine means C. That no probability. Combine G6, I6. What is G6? Total units. G6 is total units. Okay. I6 means the units out R. Okay. G6 is N. I6 is R. Then H6 to the power I6. What is H6? H6 is the F4. F4 to the power I6. That means number of units selected. Similarly, 1 minus S6, 1 minus F4. Okay, 1 minus S6, that means 1 minus F4, Q probability. Okay, 1 minus S6 to the power G6 minus I6. G6 is total units minus units out. Okay, G6 minus I6. Now the advantage in Excel sheet is that now once you write the formula for the first column, then simply you can drag. So it will be repeated. You see here, now it becomes 7. G7, I7, S7 to the power I7 into 1 minus S7 to the power D7 minus I7. Okay, that's why I have repeated all this. This is the simplest case with 1 10 megawatt. Now you do the second one. Write down the table for the second one. Second table you write. Okay. So in this case you have got 2 10 megawatt units. So as I told you, this one I have repeated so that the formula can be dragged. Okay. So this only once you mentioned, but in the exam you have to do it manually. Okay. So in this case, just write out the formulas. So first case, units out are 0, 1 and 2. Write out units out 0, 1 and 2. Okay. Capacity out and megawatt available. When 0 units are out, capacity out is 0. When 1 unit is out, capacity out is 10 because it is a 10 cross 2 system. When units out are 2, capacity out is 20. So in the first case, all the 20 megawatt available. In the second case, 10 megawatt available. In the third case, 0 megawatt available. Assuming an FOR of 0.02, what is the probability of all these cases? So now n is equal to 2. So in this case, n is equal to 2. Okay. And this is R. So what is the probability? Probability is NCR, that means 2CR. Success is 0.02 to the power R, 0.98 to the power n minus 1. Okay. So you should get this three. You compute. So in this case you will be needing only three combinations. 2C0, 2C1, 2C2. What is 2C0? 1. 2C1 is 2. 2C1 2C1 is 2. 2C2 is also 1. So this you know now. Okay. Then you can use that formula. That is NCR 0.02 to the power R, 0.9 to the power minus R. What is the R in the first row? R is 0. In the second row, R is 1. In the third row, R is 2. Compute yourself. Compute. Don't write. Don't copy this individual problem. You compute yourself. Now, compute it. Okay. Compute. All of you? First one I will compute. First one is 2C0 into 0.02 to the power 0, 0.98 square. What is 0.98 square? 0.9604. So this is fine. In the second case, it is simply 0.98 into 0.02. 0.98 into 0.02, which is 0.0390. And in the third case, it is 0.02 square. 0.02 square, which is 0.004. Okay. And when you add this up, it becomes 1. So you should cross check by adding up the individual probabilities. That should add up to 1. Next we will go for 3 5 megawatt units. Third case is 3 5 megawatt units. Now again we compute. So you have to do individual computation because this is the basic of all reliability computation at the foundation. So in this case again there are 3 units. So first case you can have either 0 units out, 1 unit out, 2 unit out, or 3 unit out. So this is R. N is equal to N is 3. So if 0 unit is out, no capacity out, 1 unit out, 5 megawatt out, 2 units out, 10 megawatt out, 3 units out, 15 megawatt out. And what is the total capacity of the system? 15 megawatt. So availability is 15 minus 0. So this is 15 minus 0. This is 15 minus 5, 15 minus 10. formula in this case, so it will be 3CR 0.02 to the power R 0.98 to the power T minus. Okay. This requires more computation, so solve after 50. All this last one is simply 0.02 cube. So that's why 8. 0.000008. First case is 0.98 cube. Right? It will be 0.98 cube. It should be equal to 0.94 1.98. Then check. Check. Cross check. Compare. All of them must compare. Always write the complete formula before this. Okay. Always write the complete formula. For example, this will be 3C0, 0.02 to the power 0, 0.98 to the power 3. This will be 3C1, 0.08 to the power 1, 0.98 to the power 2. The next is 3C2, 0.02 to the power 2, 0.98 to the power 1. Okay. For your help, I will write down what is 3C01. What is 3C1? What is 3C1? 3C1 is 3. 3C2 is 3C3 is 1. 3C2 माने what? 3C2 माने 3 factorial divided by 2 factorial divided by 1 factorial. So 3 factorial by 2 factorial. Is also 3. Okay. So did you get? Did all of you get this? Okay. Anyone who has got all the things? Fine. So we'll move to the next. Three factorial by 2 factorial divided by 3 minus 2 factorial. This is the formula. So we move to the last problem. So in this case again it's more lengthy. Okay. So here you have got 4 units. So n is equal to 4. Okay. How many units can be out? See, there are 4 units. 0 or 1 or 2 or 3 or 4. What is the unit capacity? The unit capacity is 3.33 megawatt. The unit capacity is 3.33. So when 0 units are out, it is 0 capacity out. When 1 is 3.33, 2 is 6.66, 3 means 10 megawatt, 4 means 13.33. This is the total capacity. And this one will be megawatt available. Total capacity minus all this capacity out. So this is the capacity available. Now in this case, what will be the formula? 4CR 0.02 to the power R 0.98 to the power 4 minus. Okay. Now for your benefit, so what is 4C0? 4C0 is 1. 4C1 is 4. 4C2 I will show you. 4C3 is also 4. And 4C4 is 1. What is 4C2? 4C2 can be computed as 4 factorial divided by 2 factorial 4 minus 2 factorial. Okay. So that means it is Other things you can calculate. Okay, so compute. So the first case will be I think 0.98 to the power 4. And the last case will be 0.02 to the power 4. And in between it will be 0.98 to the power 3 and so on. Like that. Okay. The rest of the class we will try with the other efforts.